Okay. We have a rubber band, which evidently is this thing, and it's stretched around 3 tubes. 1, 2, 3 tubes. Each of which has diameter 10.
10.
Okay. What's the total length of the rubber band? That's the question. Okay, so do you have any ideas on this one? I mean, do you know how to approach this at all?
Not really.
Not
Besides,
really?
it looks like it's touching it. Looks like it's touching it halfway across here.
Okay, there are a couple of facts that you need to go ahead and learn about circles, and in this case, lines that are tangent to circles. So we would say this line right here, evidently, according to the picture, it is tangent to both of the circles. Whoops. I'm trying to undo something in it.
Jumps.
Yeah, I messed it up. I'm just going to erase that line. Bring the circle back. Let me get a little bit wider line. There. This line is tangent to the 2 circles. Tangent means it intersects the circle at exactly 1 point.
Okay.
As opposed to a regular intersection. If I had a circle like this, and then I had a line that went like this, we would call that secant. And I'll just abbreviate. SEC.
You would call it what?
Secant, as opposed to tangent.
It's weird.
So here's the fact that you need to know. When a line is tangent to a circle, it forms a right angle with the radius.
Okay.
Okay, so that thing right there is a right angle, and that thing right there is a right angle. Okay, and we can draw the same picture at the bottom. It's important that the bottom thing is evidently horizontal, so we can see right away that this distance right here is exactly 10,
Okay.
because it's exactly the same as this radius plus this radius.
Okay.
Right? So the distances we care about are this distance plus this distance plus this distance. Okay? Each of those is the same.
Okay.
And it's easiest to see that the bottom one is 10. Because in order for the radius to hit the tangent line at a right angle, the radius has to go straight down.
Okay.
Which means this center point and this center point are exactly the same distance apart as this point and this point.
Okay.
Okay? And each circle has diameter 10, means radius 5. We've got 2 radii. Okay. That means that each of these green things is 10. Right? Okay, now the issue is, I'm going to try and maybe do this a little bit thicker. We want to know what these things are. Now, a very clever observation would be that if I stop here and then pick up here
It's all within
and
the
then
circle.
pick up here,
That would.
it's
those
exactly
three would
one
make a
circle. Right. In other words, each of these angles, each of these central angles,
It's 120 degrees.
exactly. And how could we prove that? using like detailed angle arguments? Well, probably I would say something like we've got to look at this triangle here, this hugeness, and show that if we can show that that triangle is equilateral, and it is by symmetry.
By symmetry?
The picture is the same.
Mm-hmm.
No matter how we look at it.
Size. Okay.
Another way to think about it too is this triangle formed by the centers of the circles is most certainly equilateral.
Okay.
It's 10, 10, 10.
Okay.
Right? And each of these lines is parallel. Each of these lines being, here I'll draw them in a different color now. Each of the lines connecting the points of tangency
Which
is
are
parallel.
now blue parts?
Yeah, they're now, because I'm coloring over. Each of these is parallel to this inner equilateral triangle. Okay?
Okay, so this one can kind of match up with this one. This one kind of goes to this one. And those are these 10 ones.
Specifically, they're
blue
parallel.
ones are the same as this one, right? They're the same length.
Same length. They're parallel with these lines. How do we know that?
But
It's
they form a
because
rectangle.
exactly, they form a rectangle. We're using the fact that any of these radii intersect
Really
a
happen.
tangent line at a right angle.
Okay.
Okay, in the end then, we've got a third of a circle, a third of a circle, a third of a circle makes
One circle.
And then, so let's put it all together. We have to publish our results here. We've got what? 3 times 10. That was this, this, and this. And then we have one circle. And what's the diameter? 10, right? All right. So I
That's
guess
certainly the right answer. I guessed that, but I'm like,
Yeah.
how did I do that?
well, one way to guess it. So here's a really sneaky thing about multiple choice questions. See how 3 of these answers have a plus 30?
Yeah?
That means the answer probably involves a plus 30.
Really?
Because the right answer is going to have the most things in common with other wrong answers. But now they penalize you for that if you look at the 20. Like if you want to use purely that strategy, both of these wrong answers involve a 20.
All 3 of them.
And this one involves a 20, but we know that's wrong.
Yeah.
All right, so that's like a little sneaky multiple choice strategy. But you can also guess these just like with, with your like pencil, meaning if I look at this length, let me this is a multiple choice test, right?
Yep.
So what we can do is we can say, all right, this length right here in yellow is about 10. It is 10, right?
It is 10.
Okay, I'm going to trace that length. 1, 2, 3, 4, 5, about 6 times. Right? So the answer should be close to 60. You see what I mean? Mm-hmm. Which of these numbers is close to 60? This is the ultimate strategy for if you have no idea. Right?
Okay.
This answer is like about 90 because it's like 20 times 3
That's like,
plus 30.
That's
This
about
answer is like
120.
120. This one's what, 105? And this one is like 45?
yeah.
So if I just like use the most, the dumbest thing I can think of, which is to measure a diameter as 10, and then like literally imagine how many times 10 goes around the circle, I get that it goes about 6 times around the circle. And this is the only answer that's even close to 60.
90 is fairly close.
Unfairly close. 45 is closer to 60 than 90.
Oh, yeah.
Okay, but the most important thing, when I have a circle and I have a tangent line, when I connect that tangent line to a radius, I get a right angle. All right.